In today's video, I'm going to be doing a chapter from 10th standard called Work and Energy. So let's get started. What is energy? Life is impossible without energy. To do work, we need energy. To do small things, also, we need energy. Then, what is its meaning? Now, let's find out what is energy. The capacity to do work is called energy. An object which has the capability of doing work is said to possess energy. The object which does not work loses energy, and the object on which the work is done gains energy. So, from this, we can say that energy can be transferred from one form to another. For example, throwing a ball with lot of force. Here, by throwing the ball, the energy from our hands is getting transferred to the ball, making it to move faster. Energy is measured in terms of capacity of doing work. So the SI unit of energy is also joules. The forms of energy. Mechanical energy. Mechanical energy is equals to kinetic energy plus potential energy. That is kinetic energy. How does bullet pierce the target? How the wind blows the blades of a windmill? This is what we call as kinetic energy. Kinetic energy is the energy possessed by an object due to its motion. It means the body moving with a certain velocity is equal to the work done on it to make it acquire that energy. Formula: kinetic energy is equal to half mv square. What is work? In our day-to-day life, we play, run and walk, talk with friends, sing and watch movies, etc. We call them as work. But according to physics, work is not that. Then what is work? So let's find out the answer. If an object is under the force and moves along the direction of force or against it, then we say that work is being done. Its SI unit is Newton meter or joule. Also, work is a scalar quantity. So work done by a force can either be positive or negative or zero. Formula: work is equal to force into displacement. Example where work is positive. A ball is moving a cart. The cart moves. It is moving along the direction of force. Lift a book and keep it in a place. The book moves along the direction of force. Example where work is negative. Climbing the stairs. We move against the gravity. If we try to stop a moving car. Example where work is zero. If we drop a ball. Talking with friends. Examples: sliding of snow, falling of coconut, crashing of aircraft, etc. What is potential energy? If we stretch a rubber band or a slinky, what happens? This is what we call as potential energy. Potential energy possessed by the object is the energy present in it by virtue of its position or configuration. It means that energy gets stored due to the work done on the object. The energy is stored as potential energy if not used to cause a change in the velocity or speed of the object. Examples: winding the key of a toy, blowing the balloon. Here, by blowing the balloon, the air inside builds up energy. And also, when we wind the key of a toy, energy gets stored in that toy. And when we release the key, then the toy starts to do movements. Potential energy of an object at a height. Energy of an object increases when it's raised above to a height. This is known as gravitational potential energy. This is because work is done against gravity. Formula is mgh. What is power? A stronger person may do certain work in less time. This is known as power. The rate of doing work is known as power. Power measures the speed of work done. It is denoted by the SI unit watt in honor of James Watt. Formula: P is equal to work done by time. Commercial unit of energy. Unit joule is too small to express large quantities of energy. We use bigger units called kilowatt hour. If we use a machine for 1 hour, then it will consume 1 kilowatt of energy at the rate of 1000 joules per second. 1 kilojoule per hour is equal to 3.6 into 10 to the power of 6. For example, electrical energy used during a month is expressed in terms of unit. Here, 1 unit means 1 kilowatt per hour. Other forms of energy: heat energy, chemical energy, electrical energy, and light energy. The sources of energies: natural gases like LPG, diesel, petrol, coal, etc. provides heat energy. Light energy like sun, light, air pressed to sea provide heat and chemical energy. Hydropower plants used to get electrical energy. Biogas like manure, methane used for heat energy. Solar energy used to get heat and electrical energy. Wind energy used to get electrical energy. Nuclear energy like uranium is used to make bombs, heat and electrical energy, etc. Geo and ocean thermal energy used to get heat and electrical energy. Tidal and wind energy to get electrical energy. Conclusion: without force, work cannot take place. Energy is conserved always. Without energy, we cannot do anything. Today, we are overusing energies by which they are getting depleted. So we have to use judiciously so that energy is conserved for future. This energy depends on the ground we choose. Energy values changes on different ground level. Work done by gravity depends on the difference in height, vertical heights of the initial and final positions of the object, and not on the path along which the object is moved. So from this, we can say in every situation, the potential energy is mgh. Law of conservation of energy. We learned that energy gets transferred, but it will never get destroyed nor be created. So we can conclude that V transforms to K. This is the law of conservation of energy. It is valid in all the situations. For example, let the object of mass m be made fall freely from a height h. At the start, potential energy is more and kinetic energy is zero. But when the object reaches ground, it would have gained more velocity, so kinetic energy is more and potential is zero. Therefore, we can say energy is conserved. Ke plus Pe is equal to constant. Sum of kinetic and potential of an object is its total mechanical energy. So by this, I am concluding this chapter, work and energy. Thank you guys for watching this video.